The question is define marginal rate of substitution and calculate the marginal rate of substitution for the utility function u is equal to q1 raised power alpha times q2 raised power beta. Okay, so first thing is first, what is meant by marginal rate of substitution or MRS? So MRS, it simply tells us it is a rate at which let me write it here. MRS is the rate at which consumer is willing to trade one good for another good while maintaining the same level of certification or utility. To put it simple, it shows us the rate at which we are sacrificing one good for another good while maintaining the same level of certification. Okay, so if I draw a simple graph here, let us say we have good x1 on the horizontal axis, good x2 on the vertical axis. Okay, so if this is our indifference curve, so it is the rate at which we are willing to sacrifice one good for another good to maintain the same level of utility. Okay, let us suppose at this point we are getting a utility level of 10. Okay, now if I sacrifice one, let us say here you have 0 1 2 3 0 1 2. Okay, so if I am moving from this bundle to this bundle, okay, how many units of good x1 I need to sacrifice for one additional unit of good x2 to maintain the same level of utility that is shown by the marginal rate of substitution. Okay, so how do we find out it for the given utility function? So let us first find out that very thing also. So we have this utility function, and the utility function or MRS is also, or it represents the slope of the indifference curve. MRS is being given by MRS is equal to, that is negative times marginal utility of good x upon marginal utility of good y. So why this negative? Because when we want to achieve one extra unit of a good, we need to sacrifice another good. That is why to maintain the same level of utility. That's why we have this negative sign here. So MRS is simply the ratio of the marginal utilities of good x and y. Now marginal utility of good x is simply, so marginal utility of good x is simply the change in the total utility due to the change in the consumption of good x. Likewise, marginal utility of good y is simply the change in the total utility due to the change in the consumption of good y. These are the partial derivatives of this function with respect to good x1 and x2. And here I have done a grave mistake. We have q1 and q2 here. Okay, so this doesn't matter, but still we have q1. Now looking here, so we have here q1. Here also we have q2. Okay, so let us show it, or let us rewrite it here. So MRS will be equal to marginal utility of good 1 upon marginal utility of good 2. That means that is equal to negative of the change in the utility due to the consumption of good q1, and mu2 means the change in the consumption due to change in the utility due to the change in the consumption of good q2. Okay, so which will be equal to, these are the partial derivatives of this utility function with respect to q1 first. So taking partial with respect to q1, exponent becomes coefficient, so we have alpha times q1 raised power alpha minus 1 by power function rule, and q2 raised power beta remains same because we are taking partials with respect to q1, divided by the marginal utility of good x, or rather good q2 is the change in the total utility due to the change in the consumption of good q2. Again differentiating with respect to q2, so we have the beta of the q2 becomes coefficient q1 remains same because we are taking the partials with respect to q2 this time, but exponent of q2 will get subtracted, so we get beta minus 1 and it is negative. Okay, that means our marginal rate of substitution will be equal to, so we have alpha negative times alpha upon beta. What we do here, let us so here we have q2. Okay, so we do one thing here, let us transpose this q2 raised power beta minus 1 to numerator. So we transpose it here and we transpose q1 to the numerator. So what will we get in the numerator? q2 raised power beta. When I transpose this, it will become q2 raised power minus beta plus 1. Okay, when we change the terms from numerator to denominator or vice versa, exponent sign changes. So in the numerator we have q1 raised power alpha. When I transpose this, it becomes q1 raised power minus alpha plus 1. So we will get here minus alpha upon beta. Okay, since bases are same, we can add the exponent, so we get here q2 raised power beta minus beta plus 1, and in the denominator we get q1, again bases are same, we can add the exponent alpha minus alpha plus 1. That means marginal rate of substitution between q1 and q2 is equal to minus alpha upon beta. So beta minus beta is 0, so we get q2 raised power 1, so we get q2, and likewise here we get q1. This is the marginal rate of substitution